Okay, picking up in lesson 2.3, right? And at the end of class yesterday, had showed you the chart on page 188 in the book, right? And we were talking about just how we were going to talk about in behavior today, but instead of using words up and down, we're going to use our limits and use infinities and negative infinities. So that's what we're going to look at on example 4. So notice the directions on example 4. Graph the polynomial in a window showing its extrema and zeros and its end behavior. Describe its end behavior using limits. So as we look at A, f of x equals x cubed plus 2x squared minus 11x minus 12. And I think probably the best bet is just go ahead and graph it. So grab those calculators and start graphing it.
Oh, shoot.
Okay. Notice one of the things it suggested once you get it up here is it says graph the polynomial in a window showing its extrema and zeros and end behavior. What can I not see on my 10 by 10 screen? Yeah, I can't see those mins and maxes, I can't see the extrema. So a couple of different tricks here. I don't know, one option, if I know how high my max is and how low my min is, I could just change the y values in my window. That's one option. Another option, or if I could guess there, if we do a zoom out, so if I pick zoom out and then hit enter an extra time, it gives me this, right? Which in my opinion is not a great view just because it's kind of too zoomed out. So this is where I would pick and use ZBox. Do you remember me showing you ZBox? I'm pretty sure I showed it, haven't I? Okay, so I would use ZBox in that, number one, draw a box around what you want to be on your graph. And to me, I kind of want this main portion, right? So if I draw a graph around that main center part of the graph that looks something like that, so it's around the main cubic part, that's what's going to make my graph easiest to see. Because now I have a pretty good visual of what's going on, if you ask me. I use ZBox, which is number one on your zoom menu. Go into zoom. Sorry, I guess I didn't say that. Go into zoom, it's number one on your zoom menu. And then you pick you put your cursor where you want one corner of the box. Hit enter. And then you draw to the diagonal corner of the box. Okay. And then it will zoom exactly what you have in your box. And then that will be and then hit enter. Yeah. So you must have not, you were probably quarantined when I mentioned ZBox is my guess, because you spent a lot of the beginning of your quarantine, so. Okay, so I'll even write ZBox on here, just as kind of a reminder. So basic picture of the graph is that shape, correct? Okay, we have it specifically on the calculator. While we're here, let's talk about something to kind of review from yesterday. What degree is this problem? This is degree 3. And what did degree 3 tell us based on, I think it was the bottom of the previous page? There are at most what? My degree is 3. At most what, Jacob?
3 zeros.
At most 3 zeros and at most 2 extrema. Okay? At most 2 extrema. Do I have 2 extrema here? Yeah, I have a min and a max. So I have at most 2 extrema. And so I'm just kind of putting some information about this problem, the fact that there are 2 extrema min and max, and it didn't really ask me to, but just kind of some information. What about zeros? How many zeros do we have on this problem? You have to look on your calculator for that one, and we have how many zeros? 3 zeros, right? Okay, so that matches up with what we talked about on the previous page. That, okay, if it's degree 3, you're going to have at most 1 less extrema, so 2 extrema, which is what it has. It has the max here. And then it can have at most n zeros. So if it's degree 3, it can have at most 3 zeros, which is exactly what it has. Now, okay, in behavior, which is what I want to talk about here. When we talk in behavior, last year in Algebra 2, what would you have said the end behavior was here? You would have said it is down and up, because it starts down and it ends up, correct? We're talking about limits here. And so as we talk about those limits, I'm going to write both of them out. And I should not have put myself at the bottom of the screen here, but that's all right. We'll make it work. So one limit is going to be the limit as x approaches negative infinity of f of x. And yes, you need to practice writing this because I want the whole notation. The other one we're going to write is the limit as x approaches positive infinity of f of x. Okay, so that's your limit notation. We have to answer them yet. So the limit as x approaches negative infinity of f of x, and the limit as x approaches positive infinity of f of x. When we talk about as x approaches negative infinity, realize as x approaches negative infinity, that's going to be as x approaches the left side of the screen. Right? As x approaches negative infinity, that's going to be as x is going left. As x approaches positive infinity, that's going to be as x is going where? To the right. That's what those are saying. So, on this graph, as x approaches negative infinity, so as my graph goes left, where is it going? It's going down, yes? So your Algebra 2 words are down. What is down in terms of infinities? Negative infinity. So this answer here is going to be negative infinity. So the limit as x approaches negative infinity of f of x is equal to negative infinity. So as x's go left, my y values are going down. That's what that's saying. What about this other one? As x approaches positive infinity. So that's saying as my graph is going right. As x is going right, where's my graph going? It's going up. What is up in terms of infinities? Positive infinity. So as x approaches positive infinity, y is also going to positive infinity. I'm putting the words in there just kind of as a beginning, as we start talking about this limit notation. I know it takes a look, while getting used to, but when it talks about as x approaches, that's an x value. Your answer to a limit is a y value there. Questions before we try B? Okay, try B. Oh, yes.
So when it's showing its extrema and zeros, we're just saying how many there is.
Well, we graphed it in a window showing its extrema and zeros. We were just kind of talking about it.
Okay.
In all honesty, it said describe its end behavior using limits. That was the key part of this. I was just kind of trying to apply what we talked about at the bottom of the previous page there. Okay? I'm going to go back and hit zoom 6 as I graph this, because who knows where this is going to be on the graph. if you watch a graph, you can see a little bit of what it's doing, can't you? I would adjust your screen so you can see it. So if you have to find those mins and maxes or those zeros that, well, I guess we can see the zeros, but we can find all of them. For me, same thing as last time. I'm going to do one of two things. Either I'm going to look at on my window, and I'm going to change my Y min and Y max. Maybe guess, higher and lower numbers. Or I'm going to play with the zoom, which I can zoom out, first of all. And then if I zoom out and it's still not there, I can play some more. Looks like that's barely on the screen. And this is a situation where, because my x's go out so wide, though, it's hard to kind of tell what, the graph is not a great view. So again, if you want a better view of the graph, I'm going to go Z-box. Again, I just have to make that Z-box like all the way to the top and bottom. The other option is you could just go into your window and change your X min and X max this time and make it closer to the graph, make it not as wide. Does that make sense? So the more you get comfortable with these calculators, the more you can figure out. So if I do Z-box, I think I pretty much have to go all the way to the top of the screen, and it won't let you go off the screen. And all the way to the bottom of the screen. And I think I can get it there at the bottom. I may cut it off just a teeny bit. I don't remember.
Oh my god.
Does it cut it off?
Mine did at least. I think I went down far enough.
Oof. Okay, well, just barely there. I'm cut off a little bit, aren't I? Which, at that point, I would probably just go into my window and change my Y min. My Y min's probably at like -20 right now. I might make it like -25 or something. And that would probably get me there. Take that back. My Y min's at -40. Sorry. So make it -45 is my guess. And hey, that worked out pretty well. Okay. So, shape of this graph. What do we call this graph? A what? Remember the word? Quartic, right? When it's degree 4, it's quartic. A degree 4 can have at most, how many extrema? 3. What's this one have? I've got 3 extrema here, right? So just kind of reviewing there. In this case, I ended up with 2 mins, 1 max. And it can have at most how many zeros? 4. And what did we end up with? We ended up with 4 zeros if you look at your calculator, don't you? Okay, so good information to know there. Now, for limit notation, I'm going to write out the same 2 starts to the limits. So practice writing those out. We're going to do the limit as x approaches negative infinity of f of x, and we're going to do the limit as x approaches positive infinity of f of x. So what's that first one asking? The limit as x approaches negative infinity. What's that saying? As x values go where? As they're going negative, they're going left. So as my x values go left, where's my graph going? Up, which is what? Positive infinity. Okay. What about over here? As x goes to positive infinity, so as x goes right, where's my graph going? It's going up again, isn't it? And so it's going to positive infinity. Anytime you have to talk about in behavior and homework, I want to see the limits. Okay? I would encourage you, don't just put answers, especially when you have to write 2 limits. You can't just tell me, oh, my answers are infinity and infinity. Okay, well, I guess it works when they're both the same, but over here, my answers are negative infinity and positive infinity. Well, which answer is negative infinity? Which answer is positive infinity? And so I want you in the habit of writing out the full limit and getting used to that notation. Okay? Now, did you guys need me to put the left, right, and up and down on here? That first one was as x goes to negative infinity, so as x goes left, and my graph on that one went up. My second one was as x goes to positive infinity, so that's saying as x goes right, my graph goes to positive infinity again, which is up again. If you don't need those words, don't put them on there. Are we okay with the limits? We haven't done limit notation before, have we? Or you guys haven't done limit notation before, have you? Okay, I didn't think so. It's a big thing in calculus. In calculus, limits are one of our 3 big topics, and so it's a big thing there. Pre-cal, it's, we're kind of at introductory level here. Get a little familiar with them. Okay. One last problem on this page. Notice there's a lot of talk about zeros and extrema in this lesson, aren't there? So this is finding zeros of a polynomial function. We're going to talk algebraically and graphically. Example 4 specifically says finding zeros of a polynomial. How? Algebraically. So this is going back to your Algebra 1 and Algebra 2 methods. If you want to get technical, I'm not going to teach anything new on this problem. But we may have to review a lot, right? So, how do we find zeros algebraically? Do we remember anything? What do we do with that equation if we're trying to find zeros algebraically? Take the equation and set equal to 0. Yep. So we're going to take x cubed minus x squared minus 6x and set equal to 0. Keep in mind, when it's asking you to find zeros, if I ask you what a zero is, usually you guys are going to tell me that zeros are x-intercepts, right? Another way to think about zeros is that zeros are also solutions to equations. Okay, so when we talk about zeros, they're x-intercepts, and they're also solutions. So if we take this equation, set equal to 0. Okay, I am teaching this in Algebra 2 today, actually. Well, we're not saying it equal to 0 today. We're doing the preliminary. What do I have to do on that left? Factor. I'm teaching factoring in Algebra 2 today. No, I take that back. I'm reviewing factoring in Algebra 2 today. Officially, factoring is only an Algebra 1 standard, which blows my mind because you guys don't remember factoring from Algebra 1. I have to reteach in Algebra 2. Okay, guys, first factoring step. What do you see here? All 3 terms have an x. So there's a GCF. Remember that vocabulary? So GCF of x, so I'm going to factor the x out front. Then I'm left with x squared minus x minus 6 equals 0. How do I continue factoring after I factor the x out? Two parentheses. So carry the x down. We've got 2 parentheses. X squared breaks into x and x. Do you remember what kind of numbers have to go here? Numbers need to give me a product of -6 and a sum of -1. What gives me a product of -6 and a sum of -1? I like it. -3, +2. How do I find my solutions? Set it all equal to 0, right? Set each part equal to 0, right? So in this case, I'm going to set x equal to 0, x minus 3 equal to 0, and x plus 2 equal to 0. So we end up with solutions of 0, 3, and negative 2. What would happen if you graphed this equation?
It would cross the x-axis on -2, 0, 3.
Yeah. My graph would cross the x-axis at those 3 x values. Okay. However, we couldn't do that because our direction specifically said to go back and practice algebraically. So algebraically, that's usually a lot of the factoring. Okay. Occasionally we have to go into quadratic formula, but it's usually the factoring. Okay. Moving along. This page, we get to talk about the graphically part. Yes?
Will there be any, like, vectoring cubes?
Like the sum and difference of cubes that we did?
Yeah.
I don't remember.
Because I don't know.
Yeah, and if it is, ask about it in class, and we'll definitely need to review that in class. It's not here in the notes, so it might not be. But I haven't looked at the homework recently enough to remember. So I can't say for sure. Okay. Okay. So as we start looking at graphically, okay, a little bit of information here. First of all, it is possible to have what are called repeated zeros. So repeated zeros is if the multiplicity of a zero is 2 or greater. This occurs if something can factor down into a quantity, squared, cubed, etc. And then they give us an example there that if f of x is x cubed plus 4x squared plus 4x, the fact that it can factor down to x times x plus 2 squared. That x plus 2 squared, that's the type where we have a repeated zero. The multiplicity is greater than 1. And I'm going to come back to that here in a moment. When this occurs, the graph many times simply touches the graph instead of crossing. And that's where it might go down, touch the 0, and go back up. So like be a minimum point. So, repeated zeros. Okay, repeated zeros occur in this type setting here, where the power on that factor is greater than 1. So when we talk about the multiplicity of a 0 is 2 or greater, we're talking about the exponent. Okay, the exponent on the 0 is 2 or greater. Meaning, okay, a lot of times we just have a single parenthesis, right? It's just an x minus 3 and an x plus 2 and an x. Well, if it, in this case, it's saying, okay, if it was x plus 2 quantity squared, because this power right here is greater than 1, so that multiplicity is greater than 1, it might, instead of crossing through the x-axis there, it might just touch it and go back to where it came from. Okay? Let's see, where does it say here? Okay, so we're going to talk about touching versus crossing. We talked about touching and crossing in Algebra 2 at one point last year. How much we looked at the graphs, I'm not 100% sure, but we talked about it. Right here. Okay, so if the power on the factoring, in other words, the exponent, right? When you hear me talk about multiplicity, that's what we're talking about. If it is even, the graph will simply touch. So if that power is even, 2, 4, 6, 8, the graph touches. So it's a min or a max at that point. However, if the factoring is odd, the graph will still cross. So when it's a power of 1, it just crosses through the x-axis, right? If it's odd, a power of 3, 5, 7, it's still going to cross. It might kind of flatten out a little bit, but it will still cross through and not create a min or a max. Either way, if it touches the x-axis, they are still zeros. Okay? So we're going to use that information here as we look at 5. And we're not going to pull up the calculator quite yet. Or I'm not going to talk about the calculator quite yet. You pull up the calculator, whatever, but I'm not going to talk about the calculator yet. So, state, in example 5, state the degree and list the zeros of this function. State the multiplicity of each zero and whether the graph crosses the x-axis at the corresponding x-intercept, and then sketch a graph. Sketch a graph is we're going to gather our information and try and sketch it. So, degree. What would you say the overall degree of this problem is? No? So when we talk degree, we would have to officially have it in standard form to be able to identify the degree. No, I'm not asking you to put this in standard form. No, I'm not asking for x to whatever, like highest power down to lowest power. But if we multiply this all back together, what would be the highest power? Not 3, 5. You guys see why it would be 5? And I get why you guys picked 3. Totally get it. X plus 2 quantity to the third, that's going to come up with an x to the third, isn't it? But x minus 1 quantity squared is going to come up with an x to the second. And what happens when you multiply an x to the second and x to the third? We're going to have an x to the fifth. So this problem does have a degree of 5. And I guess if you want to think about the fact that it's because it would be an x to the fifth, if that helps. Okay, I'll come back and talk about that here in a little bit more. Let's see. It talked about zeros. What are the zeros of my graph here? It's exactly what you know. It's easy. No work here. What are the zeros? -2 and 1, because you get them from setting each parenthesis equal to 0, correct? So I'm going to have a 0 of x equals -2 and x equals 1. Now, the next question it asks is for multiplicity. So, for the 0 of -2, what is the multiplicity of that 0? Multiplicity is, what power is the x plus 2 have on it? It has 3, right? So the multiplicity for -2 is 3. Okay, for this one. What is the multiplicity for 1? X minus 1 had a power of 2. So it has a multiplicity of 2. Now, the question becomes, state the multiplicity of each 0 and whether the graph crosses the x-axis or touches. It says crosses, whether the graph crosses. We're going to talk about does it cross or touch. So, when x is -2, that's a 0. My graph is going to touch the x-axis somehow or another. It's either going to touch it or it's going to cross through it. How do I know what it's going to do when x is -2? Okay, exponent's even or odd. In this case, my exponent is Odd. We have a multiplicity of 3. And what's it say when it's odd? It's going to cross. And so the fact that 3 is odd tells me that the graph will cross at x equals -2. Okay, that's the information you need to be able to get. This is all just from looking at the equation. I'm not doing any fancy work. So I wrote odd, and then I wrote crosses at x equals -2. What about at the 0, x equals 1? What is my graph going to look like there? It's going to touch. Because my multiplicity is even, that tells me that it's going to touch at x equals 1. So it's not actually going to cross through at x equals 1. Depending on if my graph is above or below, it's either going to touch it and go back up or touch it and go back down. Got it? So it's either going to be a min or a max there. Now, I said I wanted to do this without looking at the calculator, right? So there's a little bit more information we can get here based on end behavior. We talked about end behavior a little bit yesterday, and like in Algebra 2, how we used up, up, down, down, up, down, down, up. Do you remember anything about that? Running out of room here. We had degree 5, right? Degree 5 is odd. Do you remember if the power is odd, what kind of end behavior options we have? And here's what I go back and think. I know what x squared and I know what x cubed look like, right? X to the 5th is going to be like x to the, which one? X to the 3rd, right? Because x to the 5th is odd. And so if we have an odd degree, my options include either my end behavior is down, up, or up, down. How do I know whether it's down, up, or up, down? What causes that graph to flip upside down sometimes? A negative. If I multiply this out, am I going to have a positive or negative lead coefficient? It's going to be positive, right? Because if I do x times x times x, another x times x, that's just going to be an x to the 5th, and that's going to be a positive x to the 5th. So this is going to have a positive lead coefficient. And so positive lead coefficient, that looks like your basic x to the 3rd graph. X to the 3rd graph, it has down, up in behavior, right? It's going to start down and end up, or end going up. So that's all good information there. Not that we'd have to know it to graph it, but there's one other thing I have written in my notes. How can you find a y-intercept? How can you always find a y-intercept? Y-intercepts happen when x equals 0. So, if we find f of 0, 0 plus 2 raised to the 3rd, and 0 minus 1 raised to the 2nd. Do the math. 0 plus 2 is 0 plus 2 is 2. 2 to the 3rd is 8. 0 minus 1 is -1. What's -1 to the 2nd? +1, and 8 times 1 is 8. So we have a y-intercept of 8. Okay. Did you save any room? I saved some room over here at the right. I'm going to make my graph more top heavy. Just as you, and again, it's because I know what's going to happen here, but. Let's see. I need to be able to count at least 1 right and 2 left. And I have to be able to count at least 8 up. Okay, let's put all this information on the graph. Because anytime I go to sketch a graph, I try and put all my details on the graph that I know. We had zeros, yes? I have a 0 at -2. I have a 0 at 1. So that means my graph has to somehow touch or cross through those points. Specifically, am I going to touch or cross through those points? At -2, I'm going to cross. And I usually do this in light pencil. When I'm doing this in my notes, I just kind of put a little light C because that's indicating my brain that I'm going to cross. What am I going to do at 1? I'm going to touch. I can't really do a light, little C and T, but I just kind of lightly put it in there just kind of as a reminder to my brain that, okay, that's what I'm doing at that point. We're going to cross. We're going to touch. We know we have a y-intercept at 8. I don't necessarily know what my graph's doing at that point, but I know I have a y-intercept up there at 8. Touching at 1, crossing at -2. Okay, what's the other thing I know to help me draw this graph? End behavior is what? Down and up. So I know that we're going to start from down and we're going to end going up. And again, I kind of usually lightly draw those things in pencil and then make them connect in the end. I feel like that one's going to be a little far over. But, okay, so is that all the information I have? I think so. So if I start from down here, what's the first thing I know I have to do is I have to cross through -2, don't I? Because it had a multiplicity of 3, I'm going to kind of make it kind of jogs a little bit there. When we look at it on the calculator, you'll see it'll kind of flatten out a little bit before it continues back up. What's the next thing I know I have to do? At some point, I have to hit a y value of 8. Now, maybe that's a max. Maybe it's not a max. But at some point, somehow or another, you need to go up and cross through here. I kind of tend to just make it a max. Wait a minute here. And then where do I have to go back after I cross through it? At some point after I cross through 8. We have to touch down here at 1, don't we? So I'm going to come down here. I'm going to touch. Do I cross through? No. If I touch at 1, then what do I have to do? We're going to go back up. I tried to connect to that arrow. Not a great plan. Did you guys graph it on the calculator? Does mine look anything like that? X plus 2 raised to the 3rd. X minus 1 squared. And again, ours was a sketch, right? I'm going to do zoom 6. All those pieces came together, right? And obviously I had a little bit of information and I knew how to guide you, but we had all those pieces of information. Okay, I forgot how long that problem takes. Otherwise, my visions, we were getting done with the notes. I've got 2 more problems to talk about, don't I? Example 6, zooming to uncover hidden behavior. That is finding all of your zeros graphically. So that's using the calculator, and that's just talking about how we, you might have to zoom to figure them out. Example 7, writing a function, giving your zeros. We did that in Algebra 2. So it'll just kind of have to come back to you. Today's Wednesday, tomorrow's Thursday. Homework will not necessarily be due. My plan is I'll finish those 2 examples in class tomorrow. I would get started on the homework before then. Okay? Get started. I would love to say if we could have it done by the end of the period, but I don't think we'll be able to fully have the homework done by the end of the period. Just, by the time I, go through a couple of examples. So, get started. Probably some work time to hopefully be kind of finishing it up. Maybe we can go ahead and go through some homework questions tomorrow, depending on what you guys run into as you get started on the homework, or, I don't know, maybe with any luck, have you already started the homework at all? Okay. Parts of 34 through 54 are what you're not going to be able to do yet. That's my guess. You should be able to do everything up through 28 for sure. Okay, so definitely work through 28, see what you can come up with, and we will talk tomorrow.